Alright. Calculate the magnitude of the force on a proton traveling at this speed, 3 exponent 7 meter per second, in the uniform magnetic flux density of 1.5 Weber per meter square. If the velocity of the proton is perpendicular to the magnetic field, B, the velocity of the proton makes an angle 50 degree with the magnetic field. Given the charge of the proton is this 1.6 exponent negative 19 coulomb. Okay, so the question requires us to find force, yeah? Requires us to find the magnitude of the force. So we need to find this one, yeah? FB. We need to find FB. And it is a proton charge, okay? As the question see, it is a positive charge, yeah? Proton charge at this speed, okay, V. Magnetic flux density. Flux density actually is B, you know, magnetic field strength is the same thing. In fact, you see, magnetic field strength B unit, it has 2 units. Yeah? Magnetic field strength has 2 units. It's either Tesla, normally we use Tesla, or we also can use Weber per meter square. So magnetic field strength has 2 units, Tesla or Weber per meter square. Okay, as you can see, magnetic field strength, it has several names. It can be magnetic field strength or just simply magnetic field. Magnetic field itself also magnetic field strength. Okay, sometimes we just call magnetic field. Or we can say it's a magnetic flux density, or we can say it's a magnetic field intensity. So it has several names. Okay, all mean the same thing. B, yeah, magnetic field strength. Yeah. So as you can see, magnetic field strength also has this unit Weber per meter square. Actually, this one comes from this unit Weber per meter square. It comes from these terms, flux density. Flux density. Because we know that in chapter electromagnetic induction, we are going to learn about flux. We are going to learn about flux. This is the magnetic flux. Okay, magnetic flux. So flux is BA cos theta. This one in electromagnetic induction, we will learn about this formula. So A cos theta go below the flux. There you get the magnetic field strength, which is flux over area cos theta. Flux is the unit for flux is Weber. Area is meter square. That's why the unit becomes Weber per meter square, which is also the unit for magnetic field strength, Tesla. So that's why magnetic field strength, you can either unit Tesla or Weber per meter square. So this one is a flux density, yeah? Flux over area, because it's over area. That's why it's called density, yeah? Density. So it's flux density. That's how the names comes from. Flux density means flux over area. Okay, flux over area. That's called flux density. So that's also magnetic field strength. Okay. Now, so whenever you see these terms, yeah, these terms, this all mean the same thing. Magnetic field strength. Okay, so these are the information we have. We also have question A. He gives us velocity perpendicular to the field. That means from here we see velocity perpendicular to the field. So what does it mean by this perpendicular between velocity and magnetic field? The question asks us to find the force. First of all, let's identify the equation for force. Okay, equation for magnetic force for a moving charge like proton, okay, is QV cross B. The formula for magnetic force is QV cross B. Yeah, V cross B. Yeah, B is like the magnetic field. Yeah, B we normally put as behind. You see, the sequence is important. Normally I remember B at behind. Yeah, QV cross B. So V cross B. V cross B means Okay, it's a cross product. That's why we use sign. That's why we use sign, because it's a cross product. If dot product, we use cos theta. If cross product, we use sin theta. Okay, another thing is this is between V cross B. So that's why now the angle theta here, theta must be between the one who cross each other, which is the velocity and magnetic field. Okay, so theta is must between these two lah. Theta must between these two. Yeah, V cross B the theta must between velocity and magnetic field. And he did says that velocity is perpendicular to the field. Velocity perpendicular to the field. So that means between V and B, the angle theta is 90 degree. 90 degree. So we have the angle theta. Yeah. And then this is a proton. Proton. So the charge is 1 proton. Charge of 1 proton is the same as 1 electron. 1.6 exponent negative 90. So we have all the values here. Yeah. Just substitute inside. Yeah. Let's substitute inside. So magnetic field is 1.5. The charge of 1 proton is same as 1 electron. Okay. And then the velocity, what's the velocity? Yeah, 3 exponent 7. Okay. 3 exponent 7. And then sine 90 degree. Because between velocity and magnetic field is 90 degree. Perpendicular. Yeah, velocity perpendicular to the field. And we know that sine 90 is equal to 1. Yeah, actually is considered to be maximum. Yeah. So what's the answer? What's the answer? Yeah. So I get 7.2 exponent negative 12 Newton. Okay. So actually, whenever you have a sine 90, actually considered to be maximum force. Yeah. Maximum force at this angle. Okay. So I got this value. Yeah. Now, want the magnitude only. Want the magnitude, so no need direction lah. No need direction. Yeah. Just the magnitude. Just the magnitude. Now, how about if velocity is 50 degree to the magnetic field? So now he's saying that between the velocity and the magnetic field, it is 50 degree. It's 50 degree. Yeah, between velocity and magnetic field. So that is the angle theta. That is the angle theta. Yeah, that's the angle theta. Okay, so that's angle theta. Now, let's put the angle theta as 50 degree. Yeah, let's put as 50 degree. Yeah, let's substitute. Come on, let's substitute. So just now I got this one sine 90, which is equal to 1. So that's why the front here, actually this is the same as B. We can consider this as the BQV itself. BQV itself. So we already have the BQV. So which is 7.2 negative 12. So just substitute that inside here. We no need to substitute the others. Yeah, we already have the BQV. Because sine 90 is equal to 1. Okay, so this is negative 12. Okay, so just multiply by sine 50. Sine 50. And the answer? Give me the answer. It is 5.52 exponent negative 12 Newton. Okay, just the magnitude. Okay. So is that correct? Yeah, 7.2 and 5.5. 7.2, 5.5, exponent negative 12. Yeah, correct. That's the answer. Very easy, yeah? So remember, whenever you use the angle, yeah, for magnetic force, the angle theta must be between velocity and magnetic field. Must be between velocity and magnetic field. That's the angle theta. That's it. Yeah. Thank you. So see you in the next videos.